All right, so associated with any square matrix, and when we say a square matrix, we mean one that's n by n, such as 2 by 2, 3 by 3, 4 by 4, and so on. But associated with these is what's known as a determinant. So a determinant of a matrix, suppose I have matrix A. If I want to refer to its determinant, I can just write det A. Or I could also use determinant bars on either side. So that means transforming a matrix of this form, A, B, C, D, into this form. And these little straight up and down lines are kind of a simple design so that we know that we're talking about the determinant without having to write determinant of A. So it's just one of those math things that shows up, and you wonder, why did they switch from these brackets to these bars? Well, that's just to indicate that it's no longer a matrix. It refers to the determinant of this matrix. So what is a determinant of the matrix? Stay tuned. Let's start with the basics. We'll start with a 2 by 2 matrix. So if I want to know what is the determinant of this matrix, I'll write our DET in front of it. That means we're going to write this. Oops, wrong letter. AB on top, CD on the bottom. And what we're going to do to determine this matrix is just some simple multiplication, really. We're going to multiply diagonally to the right A times D. And then we'll also multiply negatively to the left. So that would be B times C. And the determinant ends up being the determinant of A, in this, or any matrix, is, we'll call it matrix A, is going to be the AD. These are always going to be positive, plus the negative of BC. So when we go down and to the right, those are positive. When we go down and to the left, we classify those as negative. Did I misspeak when I said that? So when we go down and to the right, positives. When we're going backwards down to the left, these are negatives. So let's look at an example. All right, so this example says evaluate the determinant of this matrix. So what that really means we're doing, but a lot of students won't write this, is it'll say, all right, let's make this into a, oops, let me get my colors correct there. Let's make this into a 5, 4, 3, 1, 2 by 2 matrix, so we know that it has a determinant. Now remember, these bars here just mean to take the determinant, multiply this, and subtract this. So let's go ahead and do that. So when I multiplied left to right, I come up with a 5. 5 times 1 is 5. When I multiply backwards, I call that, from right to left, I end up with a 12. So the determinant of this matrix is going to be the blue number, the 5, minus the red number, the 12, and minus 12 because we're saying this number is minus and this number is plus, positive. So the determinant of this matrix just very simply becomes 5 minus 12, or negative 7. Let's look at one more example. Okay, here's one more example. So we want to evaluate the determinant of this matrix. So I'll do this, and then let's be official about it here. 3, negative 2, and 6, 1. So these bars indicate that we're taking a determinant. So again, a determinant of a matrix, these bars take the place of writing determinant and having these brackets. So first thing we're going to do is multiply left to right, and 3 times 1, that's a 3, because I can put my little arrow in there, and then multiply right to left. Negative 2 times 12 is negative 12. But remember, when we multiply backwards, we have to take the negative of that. So when I figure out this determinant, it's going to end up being 3, my blue number, minus negative 12, or plus 12. So a lot of students will just write down 3 plus 12, but we find out the determinant of this matrix must be 15. So that is just a basic rundown of figuring out determinants of a 2x2 matrix. If you got value from this, share it with a friend, and thanks for watching. I'll talk to you in the next one where we use these 2x2 matrices to employ Cramer's rule.